Chapter 21, Example 1. A Massachusetts seatbelt study used a simple random sampling at 161 locations and found that female drivers wore belts 70% of the time, regardless of the sex of their passenger. Of 4,208 male drivers with female passengers, 2,777, 66%, were belted. But among 2,763 male drivers with male passengers only, 1,363, or 49.3%, wore seatbelts. How much difference is there in the proportion of male drivers who wear seatbelts when sitting next to a male passenger and the proportion who wear seatbelts when sitting next to a female passenger? So since we want to know a difference in them, we're not looking for is there a difference, we want to know what is it. That would indicate we're going to do a confidence interval. Since it doesn't tell us a specific confidence interval to go with, we'll use 95%, which is pretty much the standard value. So of course, we need to start with checking the conditions. Both samples were random, and both samples contain far fewer than 10% of all male drivers with either male or female passengers. It is reasonable to think behavior was independent from car to car. Among male drivers with female passengers, 2,777 wore seatbelts. 1,431 did not, both at least 10. For men with male passengers, 1,363 wore seatbelts. 1,400 did not, both at least 10. The conditions are met. I can use the normal model for a two-proportion Z interval. Okay, we're going to define some variables here so that we know what they stand for because we have two different groups. We need to know what represents each group, and then we're going to go ahead and show all the math on this. Normally, just use technology. This math gets very involved, so it's easier to just do the technology. Let F represent male drivers with female passengers. And let M represent the male drivers with male passengers. Okay, so you want to define the variables. F and M make sense in its context, so you'd probably be okay without, but get in the habit of always defining them. It will save yourself some trouble. So now we're going to write down some statistics in F. This is the sample size of the males with female passengers, was 4,208. The sample size of men with male drivers in M is 2,763. Now we'll find out the probabilities. In the future, it's really going to be easier just to list the statistic, but P hat for females is 2,777 over the sample size of 4,208. Where he gave us this percentage, it's 0.660. And P hat for male is going to be the 1,363 that wore seatbelts over the sample size of 2,763. This equals 0.493. Okay, now we've got to calculate the standard error. Again, remember this is standard error, not standard deviation, because we're using the sample. So, the standard error of p hat f minus p hat of m. So we want to find the difference. So I'm finding the proportion of those with female passengers minus the proportion of those with males, and that will give us the difference between those proportions. Equals, so we've got to use that big standard error formula for two samples, which we do p hat of 1 times q hat of 1 over n1. So in this case, it's over females. So I'm going to have 0.660 times 0.340. Over the sample size for females, which is 4,208. And then we're going to do the same thing for our sample of males with male passengers. The probability that a male with male passenger wore their seatbelt was 0.493, and that they did not wear it was 0.507. We'll divide this by the sample size of 2,763. This equals 0.012. So now we have our standard error. We're ready to calculate the margin of error. We're using a 95% confidence interval, so I'm using 1.96 times our standard error of 0.012, which gives us a margin error of 0.024. And we will add and subtract that from the difference in proportion. So, p hat of females minus p hat for male. So the probability that a male driver with female passengers, proportion of those wearing a seatbelt, minus the proportion of male drivers with male passengers, and this equals 0.167. And this will be plus or minus the 0.024. Now this comes out to be 0.167 plus or minus 0.024. So our 95% confidence interval will be 0.143 to 0.191. And we're ready to state our conclusion. I am 95% confident that the proportion of male drivers wearing seatbelts when driving with female passengers is between 14.3% and 19.1% higher than the proportion of men who wear seatbelts when with male passengers.